Good morning, friends. I am Vasvi Priya from Vasireddy Venkatadri Institute of Technology, pursuing my BTech second year in Computer Science and Engineering. Today, my topic is tree map from map interface in Java. Let's see what are the topics I am going to discuss today in this lecture. First, what is a map interface and what is the hierarchy of the tree map and the constructors in tree map and the methods. Let's move on to the map interface. A map interface is a collection of objects in which they are associated as a key and a value. That, that means that it is not a part of the part or subtype of the collection interface. Collection interface is the collection of individual objects to represent as a single entity. But a map interface is the collection of objects to represent as key value pairs. So the map interface is present in java.util package, and it is a representation of mapping between a key and a value. So it is a quite different from all the collection types, and it is also similar to dictionaries in Python. In Python also we will have in dictionaries in Python we will have a key and value association. In the same as in Java, we are having map interface to represent key and its value. Let me have an example. In a college we are having many classes and a list of students in each class. So each class is called as a key and a list of students in that class are called as values. So in this way, a key is associated to a value and a key cannot be duplicated. That means key should be unique. Each key can should have a unique name. Like in a college, a class or a two or more classes cannot have the same name, right? So in the same way, keys cannot be duplicated, but values can be duplicated. There are totally three classes in map interface. They are hash map, tree map, and linked hash map. See, according to our requirement, we will use any of the implementation of these three classes. In tree map and linked hash map, we can predict the order. I mean the order in which this key value pairs will be stored in that map. In that map can be predicted by using tree map and linked hash map. Whereas coming to hash map, we cannot predict the order. These are all the three classes available in map interface. Now let's move on to our main topic, tree map. Let's see the hierarchy of tree map. A tree map implements a navigable map, and the navigable map interface extends a sorted map interface, and a sorted map extends a map interface. So a tree map in Java is used to implement map interface and navigable map along with abstract map class. So in order, as I said before, as map belongs to java.util package, in order to create a tree map, we need to import java.util.treemap package and then perform all the operations on key value pairs. So what is a tree map? How is it implemented? The tree map is implemented using red black tree. A red black tree here is nothing but a type of self-balancing binary search tree. It is nothing but a binary search tree which is used to store these key value pairs. And these keys should be comparable. As I said before, in tree map we will have the keys, and these keys are sorted in the tree map and they are stored according to the sorting order of their keys. We can give that guarantee that the key value pairs in the tree map will be stored according to the order of the sorting order of their keys. So this is all about the tree map. Now let's move on to the constructors available in tree map. In order to create a tree map, there are totally four types of constructors. First one is tree map, and this is used to create with no parameter, and this is used to create an empty tree map, and the key value pairs are sorted in the natural default sorting order, and that is nothing but the ascending order. Based on the ascending order, this tree map is sorted. uh, and next, the second constructor, see, if you want, is tree map of comparator comp. means that is nothing but, see, if I want my own sorting order, the tree map provides us only the default sorting order, that is the ascending order. But I want my own sorting order, or I want ascending descending order, then I can move on to this constructor, tree map of comparator com. It is used to have our used to create a tree map with our own sorting orders. And next, if there is a hash map, a linked hash map, and you wanted to initialize it to a tree map, then you can move on to the third constructor, tree map of mapm. It is used to initialize a tree map and tree map from other maps, and the default sorting order is applied on the keys. Next is the fourth constructor. There is already a sorting order. You wanted to just initialize it to the another tree map. Then you can freely move on to the fourth constructor, tree map of sorted map SM. These are the four constructors available to create a tree map. Now let's move on to what are the methods available in the tree map. These are the following methods available in tree map. Let's discuss each of them in detail. Clear. Clear method is used to clear all the key value pairs from the tree map. Means it will remove all the key value pairs in the tree map and it will become an empty tree map. Next, the second method, clone. Clone is used to create a copy and return that copy of the tree map. This is about the clone. It is used to create a copy of the tree map and it will return that copy. Next is contains key. Suppose I want to check, is there any key in that map or not, tree map or not, then I can freely move on to the contains key method by passing my required key as a parameter to it. It will return true if the key is present in the map, otherwise false. Same as the contains value method. If I want to check whether a specified value is present in the tree map or not, then I can move on to the contains value method by passing my required value as a parameter. Next, as I said before, the tree map is arranged in some sorting order. All the key value pairs are arranged in some sorting order. So I wanted to get the last key of that sorting order. Then I can freely go on to that of last key method. And if I want to get the first key, I can move on to the first key method. I can use the first key method to get the first key that is currently existing in that sorted map. These are the methods which are used for, these are the methods. Now let's move on to some other methods. If I want to get value of specified key, there is then I can use the get method by passing the parameter of the required key of which I want to get the value. Then I can use the get method. Get method is used to return the value of which this map maps the specified key. The value associated to the specified key is written using get method. Next is head map. Head map is used to return a small portion of map. It is also map just a part of the map in which key value pairs are keys are less than that of specified key value that is passed as a parameter to this method, which the key value pairs which are less than that of passed key value, those are written as a sub map in this method. Next is key set. In key set, it is used to return a set of all the keys in the in the map on which this key set is called. Key set is used to return a set of keys contained in the tree map. Next, entry map, it is used to return all the key value pairs as a set in that existing map. So key set is used to return all the keys as a set, and entry set is used to return a set of all the mappings in that tree map. Next, all have discussed about how to retrieve the key values and the keys, etc. Now let's see how to insert the key value. So to insert the key value pairs in the map, in the tree map, we need to use the put method. Put, and we need to pass the key value objects to it. So they will be inserted into that map. Next, if I wanted to copy a set of all the key value pairs of a map into another map. Then I need to pass the map which I wanted to insert into another map as a parameter to put all. Put all method copies all the mappings from the specified map to this map. Next, remove. I wanted to remove some specified key value pairs. I don't want that key value pair. Then I can use this remove method. I will pass the key which I wanted to remove along with the key. Its associated value will also remove from the map. Next, size. I wanted to get how many key value pairs are present in that map. Then I can use the size. It will give the currently existing key value pairs present in that map. Next, I wanted to get some portion in which the key is less than that of the end key and starting from that of start key. See here I am using a submap method in which I am passing start key and end key, two keys. So I'll get a portion of the map from start key and the key till the end key and which is less than that of end key. That means start key is included in that submap, but end key is not included. It is excluded from that submap. This method is used to retain a portion of this map whose keys range from start key is included and end key is excluded. So to get a small portion of the map, you can use the submap method. Next, to get all the values in that map as a collection. Till now we have written some of the maps, some of the set, but I want it to get as a collection. Then I can use the values, which is values method, which is used to return all the values as a collection, as in the form of a collection from that map. These are all the methods to can be used on a tree map to insert, update, delete all the methods from the tree map. Next, let me move on to some example. See here, I'm taking a just small example for inserting and deleting key value pairs from the tree map. I'm initiating a tree map. I'm using a simple constructor. Here I'm using keys of integer type and values of string type. So here I am first using some constructor to create a tree map, and using the put method I am inserting the key value pairs. Here tree tm dot put of 3 comma Ganesh. Here 3 is the integer, that means it is the key, and Ganesh is a string, that means it is the value or associated with the tree integer. Next is 2 is associated with the same value Ganesh. 1 is also associated with the same value Ganesh. See here I am using same value but to different keys. So let's see how will it be sorted. Next, I'm using the fourth key value pair, that is 4 as a value and its associated 4 as a key and its associated value is this Shiva. I am just printing it. Okay, printing this map. So I'm get what I have discussed before. It will be sorted according to their keys, right? So first to lowest and in ascending order. So first lowest integer is 1, and then 2, and then 3, and then 4. In the same way, and its values are associated to that key. So whether the values can be duplicated. See here I have repeated Ganesh as 3 times. So it is duplicated, but I didn't duplicate the keys. So keys should not be duplicated in the tree map. Only the values can be duplicated. Next is how to remove. To remove, we can use the remove method and passing a key as its parameter. I'm trying to remove the fourth key value pair, that is 4 associated to Shiva. So, and again I'm printing the updated tree map. Here you can see that for Shiva will not be printed. Only Gane 1, 2, 3 key values, key and its values will be printed. This is a small example to insert and remove from a tree map. Next, this is all about today. I have discussed about tree map. I hope you all understood. Thank you.